Okay, projection at any angle. So you need to basically resolve into vertical and horizontal components, the velocity. And then you can work with these similarly to what we were doing last lesson. A little bit of terminology. So the range is the horizontal distance travelled by the projectile. Greatest height speaks for itself. Just something to think about is as the projectile moves around this parabola, the direction it's travelling in will be the same as the direction of the tangent to the curve. So at the greatest height, the vertical component of the velocity is 0. So you can use that to find the greatest height the projectile reaches. I'll go over a couple of examples. So first one. We have particle P projected with speed 28 metres per second, angle of elevation 30 degrees, and we'll start by finding that greatest height. So we're interested in a vertical height, so I'm going to resolve vertically. And with these projectile questions, I would keep up as positive, personally, because you're starting with that motion in a positive direction when you're resolving vertically, and when you're resolving horizontally, obviously it makes sense for this way to be positive because that's the direction you're travelling in. So vertically, u is equal to this is 28, so it'd be 28 sine 30 to give you the opposite, which is equal to 14. At the greatest height, the vertical component of the velocity is equal to 0. So v is equal to 0. A is equal to negative 9.8. And we're looking for S. So just choose the appropriate CVAT equation. They're all in your formula book. There's 5 of them if you need them. So for this one, we can use v squared equals u squared plus 2as. So 0 is equal to 14 squared minus 19.6s. And so from there, s is equal to 10. In an exam, it might be good just to actually, be quite explicit. So greatest height equals 10 metres rather than just leaving it as s equals 10. So just make sure you're answering the question being asked. The second thing we want to do is find the time of flight. So again, I'm going to resolve vertically. So vertically, we're starting here and we're finishing here. And so the overall displacement is equal to 0. A is negative 9.8. And we know that u is equal to 14. And we want t. You could possibly use this. If you can avoid it, I just wouldn't use previous answers in case they're wrong, but you could have used this and multiplied by 2, but yeah, I'm going this way. It's a parabola, so it's symmetrical as long as it's starting and finishing at the same point. So you can sort of delve into that if you want to, but I'd probably go with this for this one. So we need to use s equals ut plus a half at squared. So displacement vertically is 0 because it's just going up and down and finishing where it started. U is 14. And half a is minus 4.9. You can put that into your calculator, it's a quadratic, or you could just factorise it and work with it like that, but that will give you that t equals 0 or t is equal to 20 over 7. So t equals 0, this corresponds to being at the beginning, and t equals 20 over 7 corresponds to being here. So time of flight, and remember, you mustn't give your answers to more than 3 sig fig in mechanics or you will lose your answer marks, and I will have to be fussy about that. So what I would do, 20 divided by 7, I mean 2 sig figs better, because g is to 2 sig fig, so 2.9 seconds. And then for the last one, we want the range. So that's the horizontal distance travelled. So we're resolving horizontally. You don't necessarily need to write this down, I've said this before, but horizontally the acceleration is equal to 0. U is equal to 28 cos 30, because we want the bit of the velocity that's travelling in the horizontal direction, and that's the adjacent to the initial speed. 28 cos 30 is 14 root 3. So that's too accurate for an answer mark, but not for use in the question, which is just what you need to watch out for a little bit of the mechanics. And we also know t now, but I wouldn't put 2.9 in here because you might get a rounding error. So it's a bit weird, but put 20 over 7 in instead. And we want s. So we're essentially just using distance travelled is distance times, sorry, I'll try that again. Distance travelled is speed times time, in essence. But you can think of this as ut plus a half at squared. That makes life easier. A is 0, and so s is equal to 14 root 3 times 20 over 7. That gives you 69.282. And so the range is equal to 69 meters to 2 sig fig. It's probably a good idea just to write down your degree of accuracy, but actually writing it to 2 sig fig is kind of, you're kind of making the assumption that that's the amount of accuracy there is in your answer.